Hello everyone, my name is Alexander Borovikov. I am the Customer Experience Team Lead and we are glad to welcome you today on our webinar. The topic of our webinar is Smart Upgrades to your CAD Technology Stack. We will illustrate some possibilities of how you can utilize ODE CAD-related technologies in your solutions. The examples are based on our communications with ODE members. After the presentation, we will have a live questions and answers session. You can start asking questions in advance in the Questions tab. So let us start. As an intro, a simplified structure of the application. Depending on the purposes and the complexity, the blocks may vary, but there always is some data model or data storage. Data is imported to this storage in some way. Quite often, it is exported in a form of a CAD model, some widespread format, or a report. There always is some business logic that may be divided into two parts, a part that is CAD dependent and some logic that does not depend on CAD. As separate but not obligatory blocks, we may name the visual representation and the user interface with some user interaction logic. Let us review these blocks and the way ODE may be helpful here. Data import. Actually, reading CAD data is what ODE started with. On this slide, we will provide a quick overview of formats natively supported by ODE. The second list illustrates the formats from which we can import the data. As a result, this creates us an ODDB database object from which we can obtain information. The next slide, in quite the same manner, illustrates the formats to which the data can be exported. The first list shows the formats natively supported, so you can create such files from the scratch and edit them in any manner you like. The second list illustrates the formats to which we can export the data. Simply speaking, when working with the ODDB database, we get the data transferring from any to any point on the left side available, plus a one-direction data export to any of the formats of the right part.
Now, let us illustrate the input capabilities. We will use the ODE MFC application for this. We've got a DGN file and we'll illustrate your DGN to DWG import. So let us open the file. After the file is imported, in the left tab you can see the tree structure which fits the DWG file with all the key tables. We're able to visualize the data imported, pan, zoom, rotate, whatever, and we are able to save the data as a DWG file on disk. Let's click Save As, DWG extension, file name, and click Save. As you see now, in our folder we've got two files, the original DGN file and the newly created DWG file. Let us have a look at the code of how this is implemented. First of all, we go to the On File Open Menu Item Handler. And here we just load the DGN import model, and if the import was successful, we are able to add DGN extension to the list of supported extensions, so we're able to select our DGN file. After this, we go to the Open File method and pass the path to the DGN file to it. Now let's move to the DGN specifics. If you visited one of our previous webinars, you know that we've got import models for different files and including DGN. So here what we do, we load the input model, we create the importer, we set the importer properties, including the path to the DGN file, and call the import method of the importer. If the import was successful, we are able to address the properties of the importer, including the property called database, which reveals to be an ODDB database pointer object. So now we are able to operate with this object, edit the data, export data to another format, or save the data to a DWG file as we've just done. So briefly, that's it about the DGN to DWG import.
When talking about exports, we can't ignore the Publish SDK and its capabilities. Just a quick overview. We can merge data from multiple databases in one. At the same time, we can create multiple views on one page of the document, or multiple pages of the document with different views, or any other information. We can place the 3D PRC model in the document and add part list or other controls like buttons for switching between the predefined views.
Now let us have a quick view of the Publish SDK capabilities. On your screen you can see a PDF document that was created using the Publish SDK. It is a multi-page document. The first page consists of a 3D PRC model being embedded and two GPG images. The second contains two section views obtained from the RVT model. The third and the fourth contain single views obtained from the RVT model with the auxiliary texting. Now let's refer to the code of how this was implemented. First of all, we need to load the PDF publish model. After that, we need to create the OD file pointer object, our publisher, and the very document to which we will append our pages. And the first page we create, and here to this page we need to append the PRC model. We create OD-CAD model pointer and set the source of the annotation object as this model. For the model, the source is our PRC object. Now, after that, we just add the annotation to the page. Next, to append the GPG files, we create the artwork pointer object, create the image pointer object, add the image that refers to our GPG file, and then we add the text necessary. In the same manner, we operate with the second image. Also, image object and add it to the page. Now, let's move to the second page. On the second page, we had two section views. Thus, first of all, we need to read the RVT model from which we will obtain the sections. And after that, after we created the page and provided its properties, we create a CAD definition pointer. We refer the database and set the layout name, necessary layout name actually. So after that, we create a CAD reference pointer, set the clip box size, and add the CAD reference to our second page. In the same manner, we operate with the second section. Again, the CAD definition, layout name, clip boundary coordinates, and add the CAD reference and the title of the section. Page 3 and page 4 are processed in absolutely the same manner with the CAD definition, with the layout name, and etc. After all our pages are prepared, filled with data, and appended to our document, we call the export PDF and input those pdoc object, our document, and output PDF file name. So briefly, That's it.
So, when talking about the data storage, we can say that ODDB database may be a good fit for that. Due to the following. It will streamline the data flows. In case of a conversion operation, it is quite straightforward. If you do not need to support your custom storage, you can get rid of the code that performs it. Additionally, you get a bunch of the out-of-the-box features that were developed for ODDB database. Those features include a wide set of inputs, including the import of the DGN data to ODDB database. You get ready to work with the DWG extensions in case the development of your project requires it. All the examples and all the legacy code of working with ODDB database are at your service. Additionally, you delegate the support of the storage to a company with a 100 years commitment strategy. The same is true for the further development. So you can fully concentrate on your unique features and competences. The application specifics may require a custom entity being introduced and added together with the standard CAD elements. In this case, you can create a custom entity inherited from ODDB entity and implement all the necessary methods accordingly. Among those, you will implement the draw methods that will define the look of the entity being visualized. Such an entity with a custom draw implementation will be processed similar to other ODDB entity inherited entities.
Now we will illustrate an example of a custom entity. So let us open a file, a DWG file, and as you see, in the model space, there is an SDK smiley object. It is a custom object inherited from ODDB entity with a custom behavior and custom draw. Let's visualize the model and see how it looks. It's a smile object. Now let us refer the code and see how it was overdrawn. As you see, a SDK smiley is inherited from ODDB entity. There is a set of properties and methods that help to draw correctly this object. In order to process it properly, we got a class smiley model with two key methods, init.app and uninit.app. In those methods, we perform the initialization and uninitialization of the ASDK smiley object correspondingly. Now, let us switch to the implementation. In the implementation of the key methods, we see the subrow method being overdrawn in order to visualize a smiley object, and the in and out methods to save a smiley object to a DWG or DXF file, or to read smiley object from DWG or DXF file. In this mode, you can also find the sub-explode method implementation and all those methods that are referred to the visual representation of the object. The example is available in Drawings folder, in Drawings Solution, in the Examples folder. So you can refer and use it as a base for your custom entities.
Visualization of the data is not an obligatory, though quite a popular feature. Visualization is available in two options: as a native visualization for the ODDB database and as a multi-format visualization. The ESOL goes with a bunch of examples and the possibility to draw something on top of the CAD model visual representation. In both cases, you have the possibility to draw some service elements on top, for instance, the axis or a selection rectangle. Visualization is tightly connected with the user interaction. So the next features are available. Starting with the simplest ones, they are selection and highlight, moving or editing of the entity, creating a new entity. For more information, you can refer our visualization webinar and other materials.
Now, a brief illustration of the features mentioned. First, drawing on top. It's a quite familiar selection rectangle that illustrates the capability of drawing something on top of the existing image. The next one, creation, moving, and selection and editing. Thus, clicking, we can select one or several entities. We can move the entity or edit it if necessary. Briefly, that's it. The code is available in ODE MFC application, so you can refer it and see how exactly this was implemented.
If visualization is the primary goal of your application, you can consider using our visualized database as your data storage. In this case, you will get a list of ready-to-use input models that may be used as examples in case it is necessary to support a custom format. Possibility to integrate it with third-party tools, for instance DataKit integration, is already supported. A set of out-of-the-box visualized capabilities will be also available. And the compatibility with ODE web visualization may be also potentially useful. Now, let us switch to the business logic block. And here, a question of what programming language to choose for implementation is of importance. ODE SDKs are implemented in cross-platform C++, but we provide wrappers for .NET, Java, and Python. This discloses the possibilities for additional tools or frameworks usage. For instance, ODE SDKs may be integrated into a Unity 3D application. An example and an article with the key steps are in progress and soon will be available.
In this video, we provide an example of export DWG solid geometry to Unity meshes. First, we'll visualize a DWG file in ODE Viewer. You can see 27 solids in this file. That's how it looks. Now let us switch to Unity and visualize the same model in Unity. As you see, the result is almost the same, probably with some minor color differences. So we've got the 3D model. And now let us switch to the code. First of all, as usually, we do the initialization of the ODE SDKs. All the other implementation is in the load and visualize solids method. First of all, we read the file to DDB database objects. And from this file, we need to get the array of solids. After all, we'll convert this array to meshes and show those meshes. Reading files is implemented in the same manner using the xHostUpServices class. Obtaining the array of solids from the database is quite straightforward. We get to the model space and we iterate through the entities of the model space and check whether or not the entity is ODDB3D solid. If yes, we add it to the array. Converting to meshes is performed in the convert-to-mesh method. Mesh faceted settings is the auxiliary information for tessellation. You can refer the corresponding documentation for more details. After that, in the loop, we call the ODDBGetObjectMesh method with the two arrays, vertices and indices. To create and add a new mesh to the array, we use two conversion methods. To convert from DWG representation to Unity representation, we need to convert the array of vertices and modify the array of indices. Conversion is performed just to vector-free array. The indices array, as you see initially, has the following structure: the quantity of indices and actually the indices. You can see 3 and 3 indices. Unity obtains it in another structure, reverse order and without the quantity. As you see, 168 turns into 861. In the same manner, 457 turns into 754, and those 3 quantities are removed. This processing is implemented in the remove extra indices method, just in quite a straightforward manner. I get the 3 numbers, change their order, and save those indices. So that's quite straightforward. After we perform the conversion to meshes list, we'll show those meshes. It's necessary in a loop to create a game object for every mesh. Add 2 components, mesh renderer and mesh filter. And the last thing, we need to apply colors. We iterate through the game objects and obtain the color from the material, In this example, it is implemented into variants. There may be multiple variants, but 2 are implemented currently. It is an RGB color and bi-layer color. By block is not implemented. In this example, only RGB and bi-layer option. For example, as you see, we obtain the layer, we get the layer color, and create the color, getting the red, green, blue for this particular layer color. All this was performed inside the transaction, and after stopping the transaction, we uninitialize ODE. That's it.
There is one more capability that looks underestimated. It is a command approach. It is possible to implement some operations with ODDB database in form of a command. And this command may be implemented in a separate module loaded by demand. The call of the command is performed using the name of the command and the arguments being passed. Both are just text strings. It gives an extensible structure and the possibility to test a new feature separately without any effort to the core of the application. But what is probably even more important, it gives the opportunity to implement the core application, for instance, in C# and the command in C++. Using C# is more convenient in some cases, while implementing the ODDB database-related operations in C++ gives several advantages. On one hand, we can easily use the legacy code. On the other, using of pure C++ gives a higher performance compared to the usage of wrappers.
Now, let us have a look at the code and see how the command approach is being used. This is an export to SVG handler in the ODE MFC application. And you see here in this handler, we do the following. We have the string with the command name svg out, export to SVG, and a set of parameters. And this all is passed to execute command auxiliary method. Let us have a look at the implementation of this method. The key steps are the following. We create the command context. The key thing is to bind the current database we are working with. After that, we get the command stack, and using this object, we execute the command. We pass to the execute command method the command context that we created with the database and other auxiliary information, and the string that you saw initially switched to the uppercase for a correct process. The very implementation in the SVG export module. We need two key classes, the very command and the model class, inherited from ODED command and ODJS base model. In the model class, the key elements are init and are unit to register our command and to add it to the command stack, so it is possible to call it from there. In the SVG command, there are two auxiliary names, the group and global name, to distinguish our command from others, and the execute method that actually performs the execution of the export to SVG. Here you see we do the following, quite simple things. We get the parameters from the string, like line rate, scale, and so on and so forth, like precision. All those numbers in that line were the parameters that we used, and we obtain the database that should be actually exported. For all this, we create a device. That's it. Provide all the necessary options obtained from the execution string, and after everything is prepared, we just call onSize and update. So the device draws the content of the database passed to the SVG file. Briefly, that's it. Switching back to our execute command, we see that all those classes, all C++ classes that are used here, as you know, they are wrapped. Thus, nothing prevents us from implementing a similar execute command in C# and thus calling the export from DWG to SVG from a C# application in quite a similar manner. Just here for C# we pass database explicitly for our ease of the implementation. So briefly, as you see, that's it. It's possible to implement a C++ command, like here, and then we're able to call it from either C++ application or a .NET application. That's it.
And vice versa is also possible. Say you have a large C++ project and need to extend its capabilities with a feature that may be best implemented in C#. It requires some additional steps in C++ code, but is still possible. The same is true for other wrappers, for instance Java. You can have a Java application and call C++ implemented commands from it. Any existing example may be implemented as a command. And there are also many commands in ODE MFC application. Any of them may be easily added to your custom application.
And now, a quick overview of the C# implemented custom command. As the classes and methods name of the wrappers are quite similar, the implementation in C# looks quite similar to the one in C++. We've got a custom model class with two key methods, init app and uninit app, which add or remove our comment from the comment step. The next one is the auxiliary class inherited from the ODRX class with the two methods name and my parent that return the description of our custom comment or the description of the base class. And the key method, the custom comment, inherited from ODED comment with two methods that return string, group name and global name, and the key method execute that actually performs the execution of the comment. Here we get the comment context, and from this comment context we get the base database object, which is converted to a DGN database. And from this data we also get the company name, the name of the company that created this particular database, and output this name in the message. Quite simple but quite clear for an introduction of what you should implement to have your custom comment. Briefly, that's it.
Thank you very much for your attention. We hope that today we managed to provide you some new and useful information that will help to achieve your goals quicker and with less time and efforts. Now we switch to the questions and answers session.
Okay, thank you very much once more. We are very glad that you joined us. As a brief comment, I wish to say that the video of this webinar will be in a few days available on our YouTube channel, so you will be able to review it if necessary. I wish also to remind that on June 2nd, we'll have the next webinar, so we hope that you will join it as well. So please, and now let us switch to the questions and answer session, to the questions that were asked today. So the first one was about the PDF publish example, the demo. Those demos are available on our Git repository, so it is possible to review them there. It is possible to obtain the information. There are other examples if necessary. If I don't think that it is a big problem to share those examples. Probably they will require some minor adjustments, so that the developers would like to introduce some minor adjustments before sending and before sharing them. So just write me. I added my personal email to the answer of this question, so please write me, probably describe the situation in more details, so we could even probably introduce some adjustments to the example that it fits your case best and will be useful for your goal. The next one, is it possible to perform a conversion to another format, a custom format, without using vectorizers? Yes, actually there are two approaches of how the data is exported from ODDB database to other formats. One approach is, as you've correctly mentioned, is using vectorizing. So simply speaking, we create a special device and call it to draw the data in our target file. But there is another approach. We just establish a set of data conversion rules of how the entities of a DWG database should be converted to our target database, and iterating through those entities and applying those rules, we create the new file, the new of a new format. So I think a better example here is export of the data to DGN. It is a DGN export project in the drawings archive, so it's possible to open and see the implementation and use it as a base if it is similar to the one you are planning to implement on your side. The next question, which units are used for publishing for the clipbox? does it somehow relate to the actual resolution, or it's resolution independent? No, those are resolution independent numbers. It relates to the ODDB drawing being zoomed to extensions, and those numbers are taken for the clip box. So it's more correct to say that those are relative numbers, DPI independent. The next one: is it possible to import export from or to step files, or this is planned for the future? As far as I know, this is planned for the future, the support of the step files, and thus export and import. I'm not able to provide more details right now. It's necessary to dedicate some time to prepare more correct information. If you are interested, if this information is important for you, please also write me an email so I could provide you with the exact and trustworthy data on the issue. The next one: is it possible to run vectorization process only for particular objects instead of vectorizing a whole ODDB database? I think yes. So no one can prevent you from skipping the vectorization of particular entities. So you can have a look at our vectorized example. It's possible just to ignore the vectorization of particular entities and leave only the vectorization of the object or object type you need. So it shouldn't be a problem as well. The next question: what are the recommended methods to attach custom textual data, for example, pairs of key value to a database? Frankly speaking, it's difficult to say. I can pick up a relatively similar example from our practice. Looks I need some time to prepare an answer for this question, because it depends on the situation. As far as I understand, you're not talking about just plain text or text entities, so it's more complicated situation. I think probably if it's possible to provide also some additional details on the situation, if you send me an email, I would be glad to compare our existing practice and to review it and to find something similar to your case, or to discuss it with the dedicated engineers, so again to provide an exact information. So please, that was my direct email, so please don't hesitate to address. We will be glad to provide the correct information. The next question: it follows from the presentation that if we need to work with DGN format, it's better to work with DB database and its API and not with the API of DGN. Does the ODDB all DGN features? You see, the situation, it's difficult to say. You see, in this presentation, ODDB database turns to be, I would say, a universal thing, and every universal thing means some generalization in some way. So if you need some particular detailed DGN format specifics, I think it's more reasonable to work with the ODDG database and DGN API. If you wish to work in some general manner with multiple formats, for this situation, it tends to be more reasonable to use the ODDB database and just import the data from those different formats to ODDB database, and thus to process it in the same universal manner. So a short question is, it depends on the situation and on a particular task. but it's necessary to get more information about your goals and your task, because as I said, of course there is some format specifics, and if it is of importance and you do not need to work with some other formats and data, it's reasonable to work with the DG and database. If in general manners, then ODB database looks better, and it's reasonable just to import the data to it. Next question: is it possible to drag and drop block reference from a WPF panel into a WPF viewer? You see, our side is more a side of format support and related features. What you're asking is more application part, but from the implementation point of view, it is just an appending of a block reference, so copying a block reference. So we do not have limitations for this, and our API allows to do it. The thing is how to work with it in a most efficient way in a WPF example, because there you will need to work with the wrappers and some specifics that is introduced by WPF. But from the point of view of the very database API, there are no limitations, and of course it's possible, should be possible to implement this. The next question: is it possible to share ODDB database reference between the C# environment and C++ environment? For example, I read the DWG in drawings.net and I need to pass the ODDB database to drawings. Yes, for sure, it is possible, and the examples that we show prove it. Actually, you always work in C++ environment, but you work with it either directly in C++ API or by means of C# wrappers, for instance, C# wrappers. So yes, it is possible, and it will be actually the same database, but when working with the C# code, you will address it through wrappers. When working through C++ code, you will just address it directly, ignoring the wrappers. So that's it. The next question: in the PDF publishing example, the ODBM database, I think, that is used, I guess it serves access the BIM, and is the API available to standard ODA members, or is it limited to special interest groups? In other words, can you export a section view of a BIM as seen in the example? You see, the example is provided because it was presented as a multi-page example with various views and similar things. In this case, on the place of ODBM database, there could be any database, ODDB, ODDG, and whatever. Publish SDK works with all the databases supported by ODA. And yes, you are right, ODBM database is the database from the BIM via SDK. It's the SDK that is designed to support Autodesk Revit files. So in this particular example, with the multi-page PDF document, we use the Revit model RVT file as a source of data to add our sections and similar things. As for such projects, yes, BIM RV, the project that supports Autodesk Revit formats are RVT and RFA files, BIM NV, the project for support of Autodesk Navisworks, NWD, NWF, and NWC files, and extensions to DWG, Civil Map, and Mechanical. Those projects are so-called special interest group projects, and they are provided to our members with the additional license. So it's necessary to have a license, for instance, sustaining membership in ODA, and have an additional license for using BIM RV or BIM and V or any other. So it is available with the additional licensing. Any other questions? Well, we do not have new questions for now. Again, I would like to say thank you to everyone for visiting and joining us today. I would also ask you to send your feedback, comments, probably suggestions. Probably you would like us to organize a webinar dedicated to another topic. Please suggest your topics of the webinars. We'll consider your opinions. We'll be glad to establish and to hold a webinar that is interesting for you and for your goals. So please feel free to provide any of your suggestions. We've got another question, just another questions on the same topic. I do not want to run a vectorization of all the database and just ignore or filter some objects by their type or ID. It won't be an effective way. I understand your point. So you ask whether or not it's possible to explicitly specify to vectorize a particular object. Just a moment. You see, I need to double check. The first proposition is that yes, it should be possible, because the vectorization procedures are known and are clear. So it's not something we decide like on the flight. So we know how to. We've got the rules and we've got the implementation for the vectorization of the entities. So I think overall that should be possible. For additional details, it's necessary to review the code and probably to have a short consultation with the dedicated engineers. So please, I will be grateful if you send me a reminder about this question, and I will be glad to provide a correct answer. Is there a method that can select and highlight a specific object by ID, not by the bounding box? Yes, selection by ID is available. For instance, you can see this example in our viewer examples when you got a model being visualized and a tree control with the structure and with all those elements, and when you click on the element on the tree, the corresponding element on the visualized model is highlighted. So it's possible to implement this. Any other questions? Because overall, you can select just you can pick up any object by ID, and then you can do anything you wish with this object. You get the ID of the object, you call the open object or save open object of this for this ID, get the object itself, and then you do whatever you need, edit, remove, highlight, whatever you like with the object. So there are no problems about that. Any other questions? As I said, please do not hesitate. We really appreciate your feedback, your suggestions. Actually, everything we do with all this webinar session is for For our members, we try to pick up the topics that are interesting for you based on the support request, based on the questions that appear on forum. So if you can point us directly to some topics that are interesting for you, please do not hesitate to address us. As I said, it's possible to organize a dedicated webinar to a particular topic that is interesting for you. So please reach us with this information. Well, any other questions? Well, looks there are no for now. I hope if you have some questions that you would like to discuss in probably not in a public manner, but directly, please also feel free to address. We'll be glad to discuss it, to provide an exact information on the issues that are important for you. Then for now, I think we may finish today's webinar session. As I said, we'll be waiting for you on June 2nd. It will be dedicated to BIM RV SDK object model structure. The BIM RV SDK, the one that provides support for Autodesk Revit files, RVT, RFA. So thank you very much. Have a nice day. Stay safe, and we'll be waiting for your feedback, your suggestions. Goodbye.